Hi, we are Sun Direction and we will be presenting on the life cycle assessment of Ben & Jerry's ice cream. The intent of this project was to pursue the economic and environmental life cycle assessment of 1 pint of Ben & Jerry's chocolate chip cookie dough ice cream. Our goal was to help identify the environmental impacts of a pint of ice cream and to educate the general public about the impacts that come with buying Ben & Jerry's ice cream. Our functional unit of 1 pint was used to normalize all inputs and outputs through our analysis. The motivation for this LCA actually stemmed from a personal connection to Ben & Jerry's. As a cherry farmer from Oregon, my family's farm produces majority of the cherries used in Ben & Jerry's Cherry Garcia ice cream. Unfortunately, SEMA Pro, the software used for this LCA analysis, does not have cherries or any equivalent that we could have used, so we decided to analyze Ben & Jerry's chocolate chip cookie dough ice cream instead. This was done with the assumption that the overall process for all their ice cream flavors is very similar. In addition to this personal connection, we chose Ben & Jerry's due to their commitment to not only producing a high-quality product, but also ensuring that their company has a positive environmental and social impact. In 2014, Ben & Jerry's actually published a life cycle analysis of their own for their most common ice cream flavors, which we ended up using for comparison purposes in this LCA.
The scope of this LCA focuses on the transportation of raw goods from the farm to the factory, the production of the ice cream, the typical use of the ice cream, which includes both transportation to the store and the time that it spends in average freezer, and finally, the disposal of the ice cream. The boundaries of this LCA can be seen in the image to the right. For this LCA, the data was analyzed using Eco Indicator 99. This is a damage-oriented indicator method and one of the most commonly used in life cycle assessment. It was selected because of the different impact categories it includes, which are human health, ecosystem quality, and resources. The human health category focuses on carcinogens, respiratory organics and inorganics, radiation, and ozone layer depletion. The ecosystem category focuses on climate change, ecotoxicity, acidification and eutrophication, and land use. Finally, the resource category includes minerals and fossil fuels. This LCA was built on numerous assumptions due to lack of information from Ben & Jerry's. For the ingredients, amounts were based on a copycat recipe we found specifically for Ben & Jerry's chocolate chip cookie dough ice cream. If a material was mentioned numerous times or in different forms in the original recipe, it was all combined into one in SEMA Pro. For example, eggs and egg yolks were just combined together into one single egg ingredient. For the manufacturing phase, the Ben & Jerry's website was very transparent about the different steps used to make and package their ice cream. However, the actual energy consumption of all of their machines was estimated by researching similar products and scaling them up for industrial size. Waste produced throughout the manufacturing process was assumed to be negligible due to Ben & Jerry's Caring Dairy program, which sends factory waste back to the farms for reuse. In terms of transportation, most of the Ben & Jerry's farms are located in Vermont. So for this LCA, we chose to use their farm in Fairfield, Vermont. From this farm, the raw milk is sent to the St. Albans Cooperative Creamery and is then shipped to the St. Albans Ben & Jerry's factory. After the ice cream is produced at the St. Albans factory, this LCA is assuming that it is transported by truck to the King Soopers in Golden, Colorado, for an overall travel distance of about 3,300 kilometers. It was not possible to find a refrigerated truck in SEMA Pro, therefore the transport method was assumed to be by diesel-powered combination truck. During the use phase of a pint of ice cream, this LCA assumed that it was kept in a 425-liter freezer for a total of 3 days. Finally, for the disposal of a pint of ice cream, the curbside collection in SEMA Pro is used, which assumes that 20% of the waste is incinerated and 80% of it ends up in a landfill. The biggest limitation in conducting this LCA was the lack of information. Ben & Jerry's is fairly open about where their dairy comes from, but finding information about specific farming practices or details about other ingredients was very difficult. The manufacturing process for the ice cream itself was explained in much detail on the Ben & Jerry's website. However, no information was provided about the energy use of any of their machines, so there is no way of knowing if the information found online about similar machines is accurate. The available SEMA Pro ingredients and processes resulted in additional limitations. Numerous ingredients were not available directly, nor could they be realistically created or substituted with other SEMA Pro ingredients since we did not have any information about the exact ingredients used in the original Ben & Jerry's recipe. Additionally, SEMA Pro did not have an option for a refrigerated truck, so a normal diesel-powered truck was used instead, which most likely altered the transportation phase impacts. Finally, the disposal processes available in SEMA Pro were not specific to the Denver region, so that may have skewed disposal impact results.
Now, what I would like to do is analyze the results that were collected from this LCA. And the first set of data that I'd like to look at is the manufacturing phase. Now, the manufacturing phase includes the ingredients which it takes to make Ben & Jerry's ice cream, the transportation of these ingredients to the factories, and the manufacturing of these goods, and the processes in which those entail, and the energy associated with this production. Now what I'd like to do is break it down into individual components. And the first component that I'd like to look at is the chocolate associated with making the ice cream. The chocolate has a large contribution to the categories of carcinogens, radiation, land use, and minerals. Now, the carcinogens is a little bit alarming because maybe we shouldn't be eating this type of chocolate because it contributes to cancer. However, this might be a very small scale, so it might not have that much of an effect on us. Now, the second category that I'd like to break down is electricity affiliated with making the ice cream. Now, the electricity affiliates with mostly the carcinogens that are produced, which may or may not be concerning because they could use methods in which these carcinogens never actually reach a human. Also, the egg should have some examination because it does incline that it has some effect on the acidification and eutrophication on the local environment. The last category in which I would like to examine is the container in the manufacturing phase because it has a large contribution to each category of health, ecosystem quality, and resources. This is because it uses a large percentage of fossil fuels which are not necessarily clean in the environment and may cause problems in the field of respiratory health. Now, I would like to take a look at the use phase. And the use phase takes into account the transportation, which is from the factory to Golden, Colorado, and the freezer use that the consumer actually puts their ice cream into the freezer. When looking at the human health, there is not much concern from the use phase because there is practically no carcinogens and ozone layer depletion due to this phase. However, there is a little concern in the respiratory because of the production of refrigerants. And there is a little concern due to the freezer because it produces some amounts of radiation. When looking at the use phase, it is also important to take a look at the impacts that ice cream has on the ecosystem. And it turns out that the use phase contributes to 75% of all the impact on climate change due to refrigeration. It also has a large effect on the acidification and eutrophication of the climate. However, it does not have much effect on the toxicity and land use. The last topic that I would like to discuss in the use phase is regarding the amount of resources obligated to this phase. It mostly deals with the refrigerator, and this is because we assume that a typical person holds a pint of ice cream in their freezer for approximately 3 days. The last data set that I'd like to look at is the disposal of the carton of ice cream. And what this incorporates is the curbside pickup of the ice cream carton. And the main impacts that it has is on carcinogens and etoxicity due to the burning and burying of the carton itself. Now I'd like to hand it over to Angus.
To standardize the units of environmental analysis, Eco Indicator 99 allots points, which, according to Eco Indicator 99, the value of 1 point is representative of 1,000th of the yearly environmental load of the average European inhabitant. These points can be seen on the y-axis of the graph. This output gives us the total environmental load per pint, which we then extrapolated to the 22 pounds of ice cream per year that the average American eats. This then yielded, if the fictitious citizen were to eat all of this ice cream at home and store each pint for roughly 3 days on average, a little over 1% of their total annual environmental load would be attributed strictly to ice cream. But this leads us to note that very few people store just ice cream in their freezer, and if the freezer's environmental load was divided between all the food in the freezer, we suspect the ice cream's individual load would be a fraction of what we found. To provide an economic outlook on this data, our team analyzed the cost of the use phase for an individual's annual ice cream intake by taking the energy used for the freezer in SEMA-Pro and seeing how much that energy costs in Denver, which as you can see came out to roughly $18 per year. To test the sensitivity of our LCA, we decided to change the dominating factor, which, as you can see on the left, is the use phase, or the freezing of the ice cream, while holding all other variables constant. To do so, we changed our estimated freezer size from 15 cubic feet down to 7.5 cubic feet. This, as you can see on the graph on the right, shifted the environmental load majority to the production side. When we estimated the freezer cost per year to an individual, as you would guess, it decreased by roughly half, whereas the total environmental load only decreased by 30%. So, as you can see, this ability for major fluctuation quite clearly illustrates how sensitive our LCA is and how important the numerous assumptions made throughout the analysis are. This graph shows the comparison of our results to the results that we are considering to be the quote-unquote true values, i.e. the Ben & Jerry's LCA. And as you can tell by taking a quick look at the graph, there is an overarching trend in the discrepancy between the two LCAs. That is, where there is a lack of proprietary information in our LCA, the numbers vary greatly. For instance, understanding the amount of climate impact contributed by curbside pickup of an ice cream container takes very little proprietary knowledge, and as a result, our numbers match up quite well with Ben & Jerry's LCA. But when it comes to understanding the environmental load for ice cream production, our knowledge and, in turn, our estimates fail to stack up to the true values. Unfortunately, our team was unable to fully conclude whether Ben & Jerry's ice cream is sustainable. Rather, the results of our LCA are to be used as a metric for comparison, understanding the assumptions and limitations taken into account in the analysis. To improve this LCA going forward, it is our team's primary recommendation to acquire more information about the manufacturing and farming practices before taking any further steps. Once this major step is taken, various alterations can be made to the LCA to improve the output quality, such as analyzing multiple types of ice cream and ingredients, as well as changing the impact assessment method used.
This concludes our life cycle assessment presentation. We would like to thank you for listening and hope everyone has a great Christmas break and is looking forward to our podcast dropping next year.